do we model fittings? Well, you will require the specific data on your fittings. Whenever you buy a new fitting, for instance, this long radius elbow, this gate valve, or maybe this return valve and so on, the specification must come from the operator or from the brand you're buying it. So whenever you buy it, you can use their tables, or you can also make your own. Or if you don't have time of experimentation and you don't have your own data, you can use generic data. So let's see how they typically relate to velocity. Therefore, as you increase velocity, the friction loss will increase depending on the fittings right here. And right here you have the pipe size, therefore the velocities and the equivalent length. So this is very useful because the equivalent is essentially, if I were to substitute this long radius with a pipe, how long the pipe will it be in order to have the same friction loss? So of course what you want to do or to have is a very low value. So you can see the equivalent length increases as the pipe increases and velocity increases as well. And well, we're not going to do any exercise, but what I want you to imagine is how these and these right here relate to each other. Both do the same work, which is bending or moving to the right the fluid flow, but this one is very smooth. Actually, it's called a long radius because it will have less friction loss than this one right here, which crashes directly to this wall and then moves to the right. Also, the normal bend will have higher friction loss than this one right here because this one is smoothly and this is not. Also, well, the return band is also high in friction, and valves will also be very high in friction, and they depend on how which percentage they are open. You have 50%, rather 80%. Well, of course, you know that the more open the valve, the less friction. You have 95% closed. Of course, that's going to be the highest friction loss.